Keeping healthy oceans is critical to humankind. It's like I like to tell my invertebrate zoology students, 95% of the animals on this planet are invertebrates. A lot of them live in the ocean, and a lot of them evolved in the ocean. The diversity of marine life of invertebrates is very high in the ocean because that's where they all came from. I've been to a lot of climate change seminars, and even by some people who presented information that argued against the fact that the Earth is warming, what I would call sort of contrarian types. And I've never heard anybody really take on ocean acidification. I think ocean acidification is sort of the other part of climate change that a lot of people have yet to really grasp and learn about. Ocean acidification is the result of carbon dioxide from anthropogenic sources being pushed into the atmosphere. And what happens to a lot of the carbon dioxide in the atmosphere is it's absorbed by the oceans. And when you put carbon dioxide in the ocean, seawater undergoes sort of a chemical reaction with that carbon dioxide, and you end up increasing the hydrogen ion concentrations in seawater. The world's oceans have already become measurably more acidic over the last 30 or 40 years. And scientists can project how acidic the ocean should become given the amount of CO2 that we're putting in the atmosphere, and project that out into the future. The chemical machinery that produces shells has been occurring at this normal level of ocean pH, which is 8.2. So the chemical reactions that are involved in the production of the shell, as soon as you drop that pH, that's sort of acidic to the organism in a sense, and has a much more difficult time producing the shell. And even at 7.4, which still sounds fairly neutral, we've seen shells dissolve just sitting in the water for a period of a few weeks. Losing groups of organisms that produce shells, for example, could have huge ramifications on the ecology of the world's oceans. Let me give you an example. In the water column, living up in the plankton, so to speak, are small little animals called pteropods. And they're little mollusks, little snails that have a shell. And they're so abundant that they form a very important part of the food web of the world's oceans. And if those little pteropods, as they're called, are lost, you can imagine that there are ramifications for the organisms that are feeding on them. I got interested in ocean acidification because I've worked in Antarctica for 25 years. And the Antarctic Peninsula, where I've been working the last 10, has become the bellwether of climate change. The Antarctic Peninsula is warming faster than any other region on the planet. And the oceans that surround the Antarctic Peninsula and surround Antarctica as a whole, for a number of reasons, are going to be very vulnerable. Antarctic marine invertebrates that are shelled are very weakly shelled. You can pick up a clam in Antarctica and you can crush it in your hand. And the reason for this is probably twofold. One is at these very low water temperatures that you find in Antarctica, the calcification process may be a bit more expensive, so the animals have to put more energy into making a shell. Probably more important is that for the last 25 million years, there have been two conspicuous groups of animals that are missing from the cold polar waters. One is fish that have strong biting jaws, and two are crabs that have big crushing pinchers. So clams and snails and things that live in Antarctica have not had to worry about developing shells that protect them. With climate change warming the oceans of Antarctica, that physiological barrier is coming down, and it's thought that the crabs are going to move into that system now as the temperatures of the seawater are warming. So those poor invertebrates in Antarctica are going to get it from two directions. They're going to be more vulnerable to ocean acidification because they have inherently weak shells, and they may have predators moving into the system that they'll have to deal with that they've never had to deal with before. I think people need to be educated about the issue, and what we need to do as scientists is to get out there and share this information in an objective manner so that people can really take it in and make their own deductions. I now have 3 graduate students that are doing research projects related to ocean acidification. It's an absolutely vital area of research that we have to delve into to understand just how vulnerable the life in the ocean is going to be to an increasingly acidified sea.